This is a question essentially built around aqueous chemistry, although there are elements of Group 7 in there as well. But there is some quite significant Year 13 content here, so if you're looking for Group 7, I would look away now. There are 3 sections, A, B and C, 7 marks in total. Work your way through and see how you do. Here is Part A, and here's Parts B and C. So for Part A, you've really got to dig into this information and work out what you can from everything that is there. Compound A was the cream precipitate when reacted with silver nitrate solution. Now the expectation here is that you're going to remember we add silver nitrate as a test for halide ions, and we make the silver halide, which is the precipitate. Cream tells us that it's bromide, so it's silver bromide. When we get to the identity of B, we're moving into the huge swathe of facts that you've got to learn about the colours and the observations in the aqueous chemistry topic, where we look at the reactions of complexes. Now, in this particular case, though, we're looking for FeCO3. The identity of C, you were aiming for FeSO4. And the identity of D, we were looking for the fact that we've got CO2 given off. And again, on that one, you're working on the basis that when we add a metal carbonate to an acid, we make carbon dioxide gas. The final section, or the final one, identity of Y. Now, once again, you're having to build information here. We know it's going to contain bromide ions because they gave us the cream precipitate. We know from the other reactions it contains iron 2 ions. So for that reason, you would assume that it's FeBr2. In terms of the ionic equations, the basic principles of ionic equations are take the full equation, break down anything that is ionic and aqueous or molten, and then once you've done that, get rid of any spectators. In a situation with the test for halide ions, that will always come out as the silver ion and the halide ion making the solid silver halide. In this case, AgBr. Part C is another relatively common question, and you've got to be familiar and confident in building the half equation that you're going to see here, that you would be wanting to put down 2H plus and CO3 2 minus gives you H2O and CO2.